7.10, implement recovery strategies. Now, this is a task I notice has quite a bit of overlap with particularly disaster recovery. But again, that overlap and that redundancy reinforces our knowledge. In fact, I know I'm getting smarter just making these videos. And if I don't go deep enough for you, that's what our prompt at the end is for. You know what to do. All right, this task has 4 subtasks. Backup storage strategies, for example, cloud storage, on-site, off-site. 2, recovery site strategies, for example, cold versus hot, resource capacity agreements. 3, multiple processing sites. And 4, system resilience, high availability, quality of service, and fault tolerance. Let's dive in. 7.10.1, backup storage strategies. This is the backbone of your recovery plan. No backups, no recovery. So a strong backup strategy involves multiple layers, including cloud storage, on-site storage, and off-site storage. This multi-tiered approach provides redundancy and protection against local disasters or man-made intentional attacks. Disaster recovery as a service has become incredibly useful, especially with ransomware attacks. So if your systems are compromised, the disaster recovery as a service allows you to recover quickly, like near zero recovery point, recovery time objective, and without having to pay that ransom. It's a managed, scalable solution that helps critical systems get back online with minimal downtime. The exam should test you on this. Next, you conduct regular testing and validation of your backups. Testing ensures that you can successfully restore the data when needed, which is critical about the exam in the real world, right? And data encryption and access controls are essential to protect your backups from any unauthorized access. And lastly, automated backup scheduling ensures that your backups are created consistently, reducing the risk of human error and ensuring that your most recent data is always available for recovery. Each of these components work together to provide a reliable backup solution, and you can expect some questions on it. 7.10.2, recovery site strategies. Understanding recovery sites is critical for any actual plan and the exam. So 3 basic types. There's the hot site that's fully operational and can take over immediately. That's assuming that the data is there. So sometimes people have redundant site to say that the data is already processing. Warm sites are partially ready with some of the infrastructure in place, but requires more setup before becoming fully functional. And then finally, the cold site is the least expensive, but will take the most time to get operational because there's no equipment there. When deciding between the sites, it's important to think about the criticality of the business function and your organization's budget constraints as well. The exam might present scenarios where you have to choose the most appropriate site for a particular business based on cost, speed, and resource availability. And also consider resource capacity agreements. This ensures that your recovery sites have the necessary resources like bandwidth and storage to support your operations during a disaster. Geographically dispersed sites is key too. If your primary and recovery sites are in the same region, you might be affected by the same natural disaster or man-made accident, whatever. And don't forget, regular testing of any site is a must. So testing ensures that when the disaster strikes, you and your team know how to activate your recovery plan, whether it's hot, warm, or cold. 7.10.3, multiple processing sites. A very critical part of making sure your organization is resilient and avoids a single point of failure, especially for high availability requirements. When we talk about multiple processing sites, we're looking at distributing workloads across different geographical locations to maintain operations even if one site goes down. This concept connects to the ideas like load balancing, where you distribute traffic and processing power evenly between multiple sites. That way, if one site experiences an outage or failure, the others can take over without any disruption to service. Imagine how AWS and Azure are set up. A key term to remember here is data replication and synchronization. Your critical data should be copied in real time or near real time across multiple sites. That's very challenging sometimes, especially the further away, right? This ensures that the most up-to-date data is available at all time, no matter which site is active. This can also help maintain site independence. Each processing site can operate independently, and if one site fails, another can seamlessly take over through automatic failover mechanisms. Which brings us to failover. The exam will expect you to understand how automated failover allows one site to take over from another without manual intervention. This is crucial for maintaining business continuity during disasters. And multiple processing sites also brings in geographic diversity again. And as we discussed earlier, by spreading your sites out, you're reducing the risk of regional disasters affecting all your operations at once. This interconnected concept will show up in various domains as it reflects the holistic nature of security planning. 7.10.4 System resilience, high availability, quality of service, and fault tolerance. That's a mouthful, isn't it? So let's break it down. System resilience. This refers to the ability of your system to continue operating under stress, whether it's hardware failures, software bugs, or even attacks. A resilient system is designed to adapt and recover quickly, minimizing downtime. High availability. This is about ensuring continuous operation even when components fail. High availability typically involves clustering, where multiple servers or systems are grouped together to work as one. If one server fails, the others pick up the slack without disrupting service. Understanding high availability clustering and its importance in maintaining availability is pretty crucial for the cloud. Quality of service. This concept deals with prioritizing certain types of traffic over others to ensure critical applications get the resources they need. In high demand situations or during outages, quality of service policies make sure that essential services continue running smoothly, while less critical operations take a back seat. And fault tolerance. This goes hand in hand with high availability. Fault tolerance means designing systems with redundancy, so that even if a component fails, the system continues to operate. This could be anything from a redundant power supply to an extra network path or multiple devices. Fault tolerance minimizes the impact of failures and ensures continuity. The exam will likely test your ability to apply these concepts in real-world scenarios, asking how you design systems that are resilient, highly available, and fault-tolerant. And they might ask you how to prioritize critical services using some QoS stuff. All right, wrapping it up, and a couple final thoughts here. So implementing recovery strategy, again, it's going to overlap with a lot of our disaster recovery business continuity stuff, and this really what it's all about. That's, again, no backup, no recovery. So we covered backup storage strategies. We looked at the importance of diverse backup operations like cloud, on-site, and off-site storage. We talked about recovery site strategies, basically looking at hot, warm, and cold. We talked about multiple processing sites, implementing load balancing, geographic distribution, and data replication to ensure continuity in case one site fails, and overlapping with that, system resilience and high availability and fault tolerance, which are key to designing systems that can operate under stress to handle failures and prioritize critical services with QoS. And as always, these topics aren't isolated. Again, they're part of an interconnected security system. So we know that this repetition helps reinforce what's really important, protecting the common good, which is what our responsibility is as a CISSP, right? All right, let's try some stuff out on the next slide. So at this point, I shouldn't have to tell you how this stuff works again, but correlate stuff. Say, how would this affect this domain? Would whatever QoS and networking overlap with, say, the IP prioritization of service, which is hint something I love looking at. The QoS or differentiated code, DSCP code point. So take a look at those things and have fun.